Something that pretty often comes up when developing advanced applications based on Asterisk is integrating external APIs and services where there might not be an internal mechanism available to integrate with. Case in point, there are many services that use upload of audio to do speech recognition or intent recognition or text extraction, and none of them are currently supported with how either ARI or AMI works. So for those and other reasons, we usually use Adhearsion. So first of all, who am I? I'm Luca Pradovera. I'm the new principal/lead at Mojolingo LLC, which I'm sure many of you have heard about. I'm a co-author of Adhearsion, which is a Ruby framework we'll talk about more later. And I've played with phones since I was 8, because my father also is a telephony and electricity engineering. So it runs in the family. So all you need is the dial plan when developing Asterisk. That's something that came up yesterday at the DevCon, and that's something you always want to consider. Dial plan is robust and performant. It's pretty quick. It's also pretty not flexible and can get pretty complex as soon as your business logic approaches any kind of level of complexity that's beyond running a PBX, in my opinion. So what can you do? Of course, you can use many kinds of scripts and other interfaces, but you could use Adhearsion. What's Adhearsion? It is a Ruby voice application telephony framework. Does third-party call control principle, which for people not familiar with the term means it doesn't interact with media streams, but it instead deals with all the functionality regarding dialing and doing something with the call, playing audio, collecting input, connecting to ASR, all that kind of thing. We work with Asterisk using AMI and FreeSwitch through Mode.io. Version 2 is the stable version that's been around since last year, and version 3 is RC1, and we're probably about to launch version 3. It's backed by a foundation, so it's not going anywhere soon, and it's backed by people from Cisco and other big companies. What does Adhearsion 3 have new? Well, Asterisk 11 is required, but that should not be a problem for many users. Anybody that's not still on 1.4 is using at least 11 now. People that are 1.4 have a different set of problems. We streamlined the internals, is far more performant. There's a built-in HTTP server you can use to control your applications and expose data dashboards directly from the app. And it's got native internationalization support, so you can translate your audio both using text files and text-to-speech. There's a plugin architecture. You can use to plug in things like voicemail, pseudo TTS library that I wrote that gives you the ability to let's say numbers and dates without having to resort to audio files and tricks, and call queues. The call queue plugin is actually running a few of the biggest call centers I know of in the US, including the Power Home Remodeling Group call center, which Ben Klang will talk about later. There's platform-specific plugins. Asterisk does have some functionality that's not available unless you run a specific subset of commands. As you know, the AGI stuff resides in a plugin, so we can pull that in only when we need it. It's got unified logging. We can log to Logstash or text or whatever. And what's important is that, in my opinion, compared to a dial plan-based application with a mishmash of scripts, having a single Ruby app you deploy, like any standard Ruby app, makes the production environment and the general development experience far more pleasant. How does Adhearsion work? Every call is represented as an actor. So the actor model means every call is its own single process, let's call it that way. There's messages being passed between the engine and the call. So a call will say, I'm coming in. The engine will say, OK, answer. Then play a welcome. Then dial this guy. If this guy doesn't answer, dial this other guy, and things like that. Each call runs as its own handling logic, which means if a call crashes, the entire system stays up. We borrowed this concept from the Erlang framework, even through the celluloid framework that we use in Ruby. And it provides for very good stability and ease of use. Why should you use Adhearsion? As I said, when your application goes past a certain level of complexity, you want something more ready to build the complex apps that today's world demands, especially when you're dealing with WebRTC-based apps and in general, complex IVR. You can do pretty much anything. We've done calls, conferences, media, GRXML, SSML is supported out of the box, so you can specify grammars both for speech recognition / input gathering and playback, including complex ways to specify, say, dates or currency numbers. Complicated IVRs. One of my current projects is a programmable IVR. People will be able to build their own IVR using graphical interface, and then we just run that through Adhearsion, pulling the system from a database. APIs, which is what we're seeing today. Database access, you have your built-in HTTP server, and you can really do anything you want, even if it's not in the allowed by the DAO plan. You usually deploy it on any Ruby flavor that at least 1.9, but again, people are usually at least on 1.9. It's usually deployed one-to-one with Asterisk, so we have one Asterisk server and one Adhearsion process. That can be done differently. There are situations where we load balance or put together two servers differently, but it's usually one-to-one. And it's a 12-factor compatible Ruby process, which means you can run an Adhearsion app on Heroku, on the multitude of private and public clouds that are available. An Adhearsion controller can do literally anything. There's even more functionality than what you see on that Swiss knife on the left. A controller, I'll show you a more concrete example later. A controller has the ability to execute any Ruby code. So say for some reasons you can, maybe there's some threading issues you have to consider, but other than the concurrency issues, you can literally do anything you want. So what we're talking about today is chatbots and IBM Watson. You know what IBM Watson is, but just as a refresher, it's the umbrella under which IBM is grouping a bunch of services they either acquired or developed in-house. Watson is the area where they're grouping all the speech-to-text, text-to-speech, and contextual analysis, meaning analysis, sentiment analysis. It's the brand they're putting all those services under. The larger umbrella, it's called Bluemix, has even more functionality regarding anything from IoT to big data analysis to being able to compose services using a pipe, so you can have things going from Elasticsearch to something else again. What we'll be using today is the speech-to-text conversion. IBM Watson has a very good transcription engine. If you know the difference, transcription means spoken language gets converted into words, regardless of what you're saying, while a grammar-based input system means you specify the words or terms you're looking for beforehand and get exit tags as a result. And we'll be using the Conversation API, which is used to build chatbots. What's a chatbot? Chatbots have been all the rage in the news for a while, then people actually started building them and found out they are not so easy to get right from a user experience point of view. There's plenty of projects that have very good results. It's usually difficult to utilize into tuning them for the user experience. But anyways, the idea is that it's conversational text-based interface to services. You can speak to it, well, usually write to it, and it will answer you. Today, we're going to try and talk to it instead of just writing messages. They're usually text-based, in fact. They will eventually replace agents in many situations as they get better, and Watson is at the forefront of what you can do with bots. As they get better, it will be easy to replace them in situations where the operations you want to do are a limited set and they're pretty fixed. So for example, we're going to replace, very soon this very system is going to replace a newspaper delivery system where people complain if they don't get the newspaper. We currently have agents getting the calls and things like this. It's going to be turned into a fully automated system where you tell it the date and the names of the publication you were supposed to receive. It will automatically check if you were supposed to get it and then let you know if they're going to redeliver it or credit you for the missing issue and things like that. The IBM Watson Conversation API is a text-based conversation tool. You can either run it on Bluemix, which is their own cloud, which is kind of like a mixture between Heroku and I don't know, it's Bluemix. The user experience with Bluemix itself is not great, so I will advise just creating the service and then running using a JSON API. There are three different parts to a generally to a chatbot. There are three different composing parts, which are intents, entities, and dialogues. Watson is interesting because you can do both contextual communication, so an ongoing conversation where you ask for something and it will remember what you asked. You can also use it, and we do that, as a one-shot thing. So you fire a sentence at the engine, it will return the entities and meanings it found in that sentence without any context. What's an intent? An intent are the phrases a user can say. So what you do, what you can see on the right, even maybe it's not very readable, Watson will ask for examples. So for example, what you see on the right is the turn on example. So the bot I'm going to be demonstrating later is about the turn that operates a car internals. So you ask it to do something with the car, like turn on the lights. An intent will be turn on. So turn on will have many synonyms. So those are all the phrases you can say to get the turn on intent. The engine will return the intent of turn underscore on with a hash in front, basically telling you, this guy that's speaking to me is telling me to turn on something. But what is he asking me to turn on? An entity. Entities are a list of available terms you can use together with intents when speaking to a bot. So for example, if I ask to turn on music, the next thing I will want to provide is a list of entities for genres. And as you can see, there's a list of basic genres to the left and a list of synonyms going on. So jazz is also big band and Dixie and lounge and swing. Rock is jam, metal, prog, and whatever. They provide values for a context. So you're going to use an intent plus an entity. Turn on music. Jazz music will be the entity. A dialogue ties everything together, and it provides transitions. It is granted only used in conversational bots, not one-shot things. So you start from the intents and entities you defined earlier and connect them and tell the engine that if someone wants to turn on something but doesn't tell you what they want to turn on, first thing he has to ask you is, what do you want to turn on? Music. If it's music, then ask them which genre they want to hear. And when they say a genre, say we're turning on that music. This is also where you specify the text that Watson will actually say to the people calling. Just as an aside, TTS, again, it's a transcription engine. It's not grammar-based, so it's free-form. You just speak to it, and it will try and turn the speech into text. It's available through streaming HTTP, sessionless REST. You can just post audio files to the API, and it will return transcriptions, which is what I'll do later. It also has a WebSocket interface and an async API interface where you can send in the file, and then it will post to you when it's done. The interesting thing is that it allows for custom language models. Custom language models means you can define terms, even make up words, and then use them in your application. So I'm working through a project right this moment where we're just at the design stage where they'll be doing closed captioning, live closed captioning through IBM Watson. And there will be a need to define specific terms that mean punctuation. So for example, they do something like speak one, and it means a dot. I can tell, or a full stop. I can't tell you why they do this kind of thing, but it's apparently how live closed caption is actually done these days. So we'll be defining specific terms that the engine will then turn into punctuation, so the closed captioning can be high quality and read like a normal text, as opposed to the usual short-form closed captioning that you see has no punctuation, and it's usually just a stream of simple words. Haha, dangerous demo time, because people that have less courage just do demos during the dangerous demo time, but I'll do it in my own presentation. Okay, so let's see if the app is already spun up. Yeah. This is just the adhesion log, and I'll call any number, really. So this is just a simple setup. I have an Asterisk virtual machine, Lumen Box virtual machine doing the TTS. In this case, the ASR is done by Watson, and I'm just using a simple SIP phone to connect to the app.
Hi. It looks like a nice drive today. What would you like me to do?
Turn on the lights.
Okay, turning on the lights.
What can I do? Can be a
I'm
little...
trained to turn things on or off in the car dashboard, play music, and find nearby amenities like restaurants, gas stations, and restrooms.
Find the restroom.
I've found the closest restroom stops. Which one would you like to drive to?
The nearest one.
Okay. Navigate. First restroom. We should get there quickly.
Thank you.
Sure. Let me know if you have more requests or questions.
So that's it in a pinch. What you saw? Oh, don't look at the exception on the screen. That didn't happen. Okay, so aside from this is just the official Watson demo. I piggybacked on using ASR to make it a voice-based bot instead of a text-based bot. But think about the possibilities. This could be literally anything, and this has the ability to access databases. This has the ability to extract entities from context, so you can know what a person is talking about. There are even more complicated APIs I haven't used in this particular demo. We're using in production projects, such as Alchemy. Alchemy will actually try and extract meaning from unstructured text, which means you can transcribe a voicemail in your system and then find out if the person that wrote the voicemail, that left the voicemail was angry or happy or really needed something, or they just wanted to ask if you're going out for dinner. For example, grade it based on importance. So is this message important? Yes or no? Like Google does with the Gmail, that yellow arrow it will put on the left if it thinks the message is important. So in a pinch, that's probably, in my opinion, this is one of the futures of IVRs and applications in general, just because it's so cheap to operate one once you built it, compared to having live agents. We've estimated you could cut down live agents in an inbound call center to about 1/4. So if you have 10 people now, you want just 2 or 3 after you implemented this kind of strategy. So it will be extremely cost-effective for the industry too. So it's not something for developers only. This is something everybody has to keep in mind going forward, because many of us have businesses in the traditional call center sense of things. We have customers. Most of our customers have a call center of some kind. And that's going to be more important as we go forward. So just a quick detour about just showing you what Adhearsion controller looks like. There's a run method that has the various functionalities. As you can see, we use a readable DSL. So we answer, 100 times we get the conversation step, then record and recognize. Without going into detail, what we do here is we record the entire audio and then post it up, because Asterisk doesn't have streaming HTTP ASR. So what happens is that that's why the bot felt a little slow. What was happening there is that I was recording the audio, uploading it to Watson, getting the text, using that to ask a question to the conversation bot. So there's 2 APIs that work here. To finish your presentation, you might be asking yourself, well, who's using Adhearsion? Well, we have plenty of customers and non-customers using Adhearsion. There's RingerX, which is the only HIPAA-compliant phone system. They have 2 services, a cloud PBX and an on-call service that connects doctors to people in case of an emergency. What we replaced there is really just a very complicated dial plan, instead using a few simple Ruby rules that directly access the database to check if you're allowed to call that doctor at that time, or who's the available doctor for this specialty at this time, things like that. Live Connect. This is my newest project, and it's a surgical procedure broadcast system. We got given a black box, literally a black box, which is a FDA-approved camera they can use in the operating room, and it's SIP only. And we had to build a system around that, because that could not be changed, because certifying another device will have cost tens of thousands of dollars, if not more. There's 1 SIP broadcaster and WebRTC clients. This admittedly runs on FreeSwitch, so don't stone me. And just because it was built on FreeSwitch, there's no real reason. It was started on FreeSwitch by someone else, then they called us to finish it, and it stayed on FreeSwitch. Anyways, there's WebRTC clients that can connect, In this case, Adhearsion provides mostly the security access. The app itself is simple, but you absolutely don't want anyone accessing operating room, video, and data unless they are allowed to, because, as you know, that's very sensitive data for many reasons. So what we do with Adhearsion is check that nobody is allowed to enter a room unless they actually have the authorization. The rest is just a simple conference room. The other sort of interesting thing there is that the SIP camera has a few commands you can activate through an API, and we do that through Adhearsion, so you can switch the view. The camera is actually projecting 5 different video feeds, if I'm not mistaken. You can switch what you're seeing remotely, and also recordings and moving. Recording handling is actually pretty important. Many times you want to move your recordings somewhere else after you're done recording, or do something with them, run them through SOCs. And for example, my demo I did before was running each audio file through SOCs, because currently Watson only supports stereo wave files at 44K quality, while we're recording at 8K. So I'm just transcoding them to 44K 2 channels. They don't actually gain resolution, as you know, but at least Watson will accept them. Power Home Remodeling has 400 call center operators, might be closer to 500 now, and they're running millions of calls a year on a single asterisk box with a single Adhearsion instance. So I can say we're pretty satisfied with the performance here. It's not very relevant. It's a very big customer, but it's also probably not very relevant from a purely development standpoint. Like, this app literally does nothing else than call people. But it shows how Adhearsion doesn't really tax the system much more than just using the dial plan. You're most probably going to reach media bandwidth issues before you start having Adhearsion call setup issues. Usually having 400 to 500 calls on a single box is the problem with the media, not performance itself. So that was it in a pinch. Thank you. Again, my name is Luca Perdovera. I am a voice application developer at Mojolingo. Hit us up if you need anything, just questions, or we can help you with anything. And visit us, and don't check out my Twitter feed, there's nothing there. Check out the Mojolingo one, it's more important. And do look at my GitHub, where the demo code for this project will appear as soon as I'm removing my actual Watson keys from the project and replacing them with environment variables, which is something I didn't get to in the morning, so I could not push the code yet. Or you'd be using my API keys, which is fine, but might turn expensive. So if you have any questions, I'm glad to answer. Everybody seems happy.
Any questions? Here, let me give you the mic.
Just wondering how long it took you to build this demo, just ballpark.
So keep in mind, I know both systems very well, but I think it was a couple hours of work. Really, again, if this had to go in production, there will be a week more of work to do the environment around it, but the code is a couple hours, not more. The demo is like 50 lines of code.